Hi, my name is Ilze Pretorius, and I am an atmospheric dispersion modeler here at Scion. I am involved in the development and testing of a smoke forecasting system for New Zealand, along with a team of colleagues and collaborators. But before I go into more details about the smoke forecasting system, I think it is important to look at what exactly smoke is and why it is a health concern. Smoke consists of a number of particulate and gaseous contaminants, including fine particles, carbon monoxide, nitrogen oxides, polycyclic aromatic hydrocarbons, and volatile organic compounds. Population health exposure studies are mostly concerned with fine particulates as it poses the greatest health concern, but exposure to the full mixture of contaminants present in smoke is likely to have additional health impacts that are currently very poorly understood. Why are we concerned about fine particulate matter? Particulate matter is defined according to its aerodynamic diameter, and it's often referred to as PM10, meaning particulate matter with an aerodynamic diameter of 10 micron or less, and PM2.5 with an aerodynamic diameter of 2.5 micron or less. The size of these particles with reference to beach sand and the human hair can be seen in this illustration. The finer or smaller the particle, the more toxic it is, as it can penetrate deeper into the lung and get past the body's natural defenses. PM2.5 penetrates all the way into the lungs alveoli, where it gets taken up by the bloodstream. Here it causes health impacts, including respiratory illnesses, heart conditions, stroke, and some type of cancers. Particulate matter also blocks out light and therefore reduces visibility on roads, in the sky for aeroplanes, and impacts on tourism. The benefits of smoke forecasting is therefore to warn people of smoke impacts so they can change their behavior to reduce their exposure to smoke. Children, the elderly, and people with pre-existing health conditions are especially vulnerable to the health impacts of smoke. Behavioral changes include staying indoors, closing windows and doors, school closures, and even evacuations. The image on the left shows the massive smoke plume from the Australian wildfires reaching all the way past New Zealand as captured by a satellite from space on New Year's Day this year. The image on the right shows the impact of this plume on the Auckland air quality. The New Zealand Blue Sky Smoke Modelling Framework consists of a chain of independent models that are interlinked. Each link in this process answers a specific question, such as, what fuels burned? How much of it burned? What type of day did it burn? How much smoke was released? At what height was the smoke transported? And where will the smoke go? This eventually leads to smoke dispersion modeling. The system takes two inputs. Firstly, it takes fire intelligence, such as the location and size of a fire, that currently comes from satellite fire detections, but this will later also include ground observations, helicopter and unmanned aircraft perimeter data, and call-in information. The other input is numerical weather prediction data, necessary for predicting where the wind will transport the smoke to. The New Zealand Blue Sky Smoke Modelling Framework is currently in its beta version, meaning that it's still being developed and tweaked for the New Zealand environment. It is currently running twice per day operationally, and it has already been used during a number of New Zealand fires, such as the Port Hills fire near Christchurch in 2017 and the Pigeon Valley fire near Nelson in 2019. This video shows the predicted smoke dispersion from the Australian bushfires over New Zealand earlier this month. This is a video of a smoke forecast that was done during the Pigeon Valley wildfire in February 2019. During this fire, a number of communities were evacuated to reduce their smoke exposure. Thanks so much for the opportunity to present to you today. If you have any questions or comments, please do not hesitate to contact myself or the Rural Fire Research Leader, Tara Strand. Thank you.